two exponentials in every term that form those determinants. Anyway, this is 1, and that's also 1, so the answer was just e to the 2x, e to the 2z.
I got that it failed.
What's that?
I somehow got that it failed, and I feel like it was on the basis of that caution singe not being.
I don't know. I got e to the 2x plus z, so. Did I not take points off?
No, I have that. I think I have that.
I got E2x, E2z. Yeah, that's what I got.
E2x, E2z? Yeah, okay.
Same thing.
Uh-oh.
Same thing.
No, I got that somewhere in the.
Huh. Now, it's not injective, though, because if we look at, like, for example, 0, 0, 0, 0, and 0, 0, 0, 2 pi, they both give us, what's that? Ah, good, good, yeah. So
I was a little bit more
I had tried to use, we really want a specific example to prove not injective, right? But if I had been doing a better job of my grading, I would take points off. But all right. Next up here, this one is diagonal. The Jacobian matrix is diagonal. This is even easier to calculate the determinant. Just multiply the diagonals. And so as long as that's, I don't know what happened here. I thought I was going to do something, and I guess I decided against it. Anyway, so I guess that's good enough, a description. So to solve, these equations actually solve pretty nice. You might recognize this from from manifolds. I like this example so much I had to bring it back because they should see it too.
I thought it was analysis.
Oh, that's where it was, analysis. I can't. All the semesters run together for me. This is a nasty problem. A nasty problem. This problem is born from the dark heart of complex variables. For this is nothing more than the z cubed map. This is f of z equals z cubed written in Cartesian coordinates.
You circled my boom.
Boom. Ah, yes, I saw the boom. So if you do try to solve it, so if you guys got stuck solving it in Cartesian, not surprising. It's very, very hard to solve directly through Cartesian methods. If you change to polar coordinates, though, and you do the appropriate trigonometry, it gives you this and that and that, and then you can solve it for inverse tangent of this, and so you get, so you get through it. Eventually, I get this solution, which is, so like this argument is really just theta, right? So essentially it's like calculate the angle of uv, cosine of 1/3 that angle, sine of 1/3 that angle, times the 6th root of the sum of the squares. That ends up being the inverse. I obviously wouldn't ask that on the test because not all of you have had complex analysis, but in homework I ask harder things. So yeah, this is actually how I come up with the problem. And you can, is it 3z squared? No, it's z cubed. This is a prime here. F prime is 3z squared.
Just accidentally wanted to divide to get this.
Yeah, thank you. So anyway, but you can actually understand where the Jacobian matrix is coming from if you look at that F prime is 3z squared. If we look back at the Jacobian, we'll see the 2x2 matrix, the A minus B, BA matrix for like complex numbers. You'll see that there for 3z squared being 3 times x squared minus y squared plus 6ixy. If we go back to the Jacobian, we'll see x squared minus y squared, 3 times x squared minus y squared for the real component, and 6xy for the imaginary. That's what I just said. Anyway, my more evil bonus problem is based on the reciprocal function in the 3 hyperbolic numbers. If you can manage to get through it, the inverse function is what? Anybody done that one?
I tried.
You tried? Okay.
Where's 5 points?
I need dirt.
You need dirt for 5 points? Well,
It's not that bad.
It's not worth it trying to work one.
are we talking about like, well, see like, so my my best friend growing up, his mom made this dirt stuff, but it was like with Oreo cookies, so it's actually kind of magical.
I need that for 5 points too.
Yeah.
Would it be better using my time to study for the test? I'm more likely to score 5 points higher if I spend the amount of time doing the bonus problem that I did.
Quite true.
Just which one of these?
Quite true. What's your goal here?
To get there.
What's your goal here, Violet?
Okay, so I will. All right. So any questions about this, you guys? You know, here's some quick test strategy stuff. If I ask a question about normal space and tangent space, a quick way to check to make sure you're on the level is if you have a basis for the normal space and a basis for the tangent space, they ought to be perpendicular. It's pretty easy to calculate dot products, right? So like if I did this right, it should be the case that this and this and this dot that is 0. And you can see that in fact it is, right? So, yeah.
Do you care about just
The-
P cross span, the second thing, P cross span?
You could do P cross the span instead of that. You could forget to draw the P. If your heart's in the right place elsewhere, I probably won't take points off. You know.
You don't really.
Yeah, for lack of a better
Okay.
word. I wish I had that.
Educated kids.
I've tried to do it. I've tried to be consistent in my, you know, basing the vectors at P this semester, but at some point or another, I'll slip up and forget to write the P.
Do the same thing for 4, 'cause it's just geometry.
So like here,
By inspection.
this, you know, I did try to take some time to, you know, make a little video about how to calculate the null space. That's important, right? Because if I want to find the vectors which are perpendicular to 2, 4, 0, 0 and 0, 0, 6, minus 8, what I do is I do row reduction on this, I get to that, and once I've found that, if I have v1, v2, v3, v4 in the null space of this matrix, then I can read off that's v1 minus equals to minus 2v2, and v3 is equal to 4/3 v4. And when I plug those equations back in here, that reveals that I get this vector and that vector as perpendicular to those two. See how that works? This dot that is 0, this dot that is 0, this dot that is 0, this dot that is also 0. Now, you don't have to be a slave to this calculation either. If you'd like, you can simply guess. Right? We're talking about this vector. How do you find something perpendicular to it? Just flip the 4 and the 2, right? But the issue is you got to make it perpendicular not to this alone, but this and that. It just so happens these zeros make that easy. You know, if they don't have zeros, if it's 4 things that are non-zero, well, we've seen how the calculation actually has to go through. But I'm interested in results. Okay, so like, if you don't need to do the null space calculation, by all means. Anyway, I'm going to shut up. You guys have a good weekend. And if you got questions, feel free to ask. What's that? Can you have your points back? We should have thought about that before you posted that offensive picture in your homework.